Hello. In this video, we are going to be looking at the rules of inference, which are rules for inferring conclusions from premises in a valid manner. And validity is something which preserves truth, so that if you infer in a valid manner, if you have true premises, you'll get a true conclusion. So these are rules for getting true conclusions from true premises. Let's recap what we learned from the previous video on good arguments. We learned that an argument consists of premises and a conclusion, the premises being given as reasons for believing the conclusion. And a good deductive argument is a sound argument whose premises are evident. A sound argument is a valid argument with true premises. And a valid argument is one whose premises imply the conclusion such that the conclusion must be true if the premises are. So let's take a closer look at validity, which will be the main topic of this video. An argument is valid when its conclusion necessarily follows from its premises. For example, some roses are red, therefore some roses are colored. This is valid by virtue of the meaning of red and colored, because we know red is a color. But this argument is not formally valid. An argument is formally valid when, regardless of the meaning of the premises and conclusion, its form guarantees that its conclusion must be true if the premises are all true. Here's an example similar to the previous example. Some roses are red. Whatever is red is colored. Therefore, some roses are colored. This has the same premise as the original argument, but we introduce a new premise. Whatever is red is colored, and this premise connects the original premise with the conclusion such that we have a valid argument form. And the thing about an argument which is formally valid is that any other argument of the same form will also be valid. So we may change some of the words here, such as red to dead, colored to rotten, and we still have a valid argument. It now reads, some roses are dead. Whatever is dead is rotten. Therefore, some roses are rotten. However, it's not a sound argument because this premise here is false. We cannot say that whatever is dead is rotten because there are some dead things that are not rotten, such as fresh kills, or dead meat, or perhaps in the case of roses, cut flowers. And if we go back to the previous argument and make the same changes, say some roses are dead, therefore some roses are rotten, we do not have even a valid argument here because the meaning of dead is not tied to the meaning of rotten like the meaning of red is tied to the meaning of the word colored. Okay, let's look at the rules of inference here. We see various letters in the rules of inference. These letters are placeholders for propositions. So we have P, Q, R, and S. We can replace these with propositions and have longer propositions. And we also have logical operators here. We have a horseshoe, which means if then. It says there's a conditional here, so this means if P is true, then Q is true. Here we have the tilde, which means not. This means that Q is false. Here we have a wedge shape, or a V, which means or. So this means P is true or Q is true. And over here we have an ampersand, which means and. So this means P is true and Q is true. Now, before we delve into the rules of inference in greater detail, let's take a closer look at just what propositions are, because propositions are what we're going to be plugging into the placeholders here. Well, the premises and conclusion of an argument are propositions. A proposition is something that is true or false. Although propositions are expressed with sentences, a proposition is the meaning of the sentence, not the words, marks, or sounds used to express it. So different sentences may express the same proposition. Here are some examples of different sentences expressing the same proposition. This cat is fast. This feline is quick. Diese Katze ist schnell. Ce chat est rapide. Here we have a French and a German translation of the original sentence. Also, not all sentences are propositions. Questions are not propositions, such as, why am I not subscribed to this channel? Exclamations are not questions, such as, if only I were subscribed to this channel. And commands are not propositions, such as, subscribe to this channel. Also, propositions are not thoughts. Although a proposition may be thought, and no one would have any notion of propositions without thinking them, propositions are not the thoughts of them. The same proposition may be thought by different people in different times. Also, propositions are abstract. A proposition is not any concrete thing or quality it might be about. The proposition that the sky is blue is not identical with the sky nor with the color blue. Like numbers, propositions are completely abstract. Because of this, propositions do not even have to refer to real things. We may have such propositions as Superman is Clark Kent, or the flying spaghetti monster has a beer volcano in his heaven. And although a proposition must be true or false, this does not mean that we must know whether it is true or false. Here are some examples of propositions which many people accept as unknown. Many people do not know whether God exists. This includes many atheists who, although they don't have a belief in God, do not go to the extent of denying that there is a God altogether. There are atheists who will take the position that there is no God. There are other atheists which simply don't know one way or the other and choose not to have the belief that there is a God. Also, the proposition, there is life on Mars. Well, there is evidence of life on Mars, such as some methane being measured by the robots that we sent up there. There's also things on Mars which look like they might be fossils, but we have not ascertained whether they're fossils or not. So there's some indications there could be life on Mars, but we don't have any concrete evidence of life on Mars. Or take, there is a sea monster in Lake Champlain. There have been rumors of a sea monster in Lake Champlain since, I believe, the time of Samuel de Champlain, or even further back with the Iroquois and Algonquin Indians. But there has been no concrete evidence of a sea monster in Lake Champlain. There are no good photographs of one there, and no monsters have been captured. No monster carcasses have been found in the sea, in the lake. So there are people who believe there's a sea monster in Lake Champlain. There are people who don't. Also, a proposition is always true or always false. It does not change its truth value over time. And this may be one of the more unusual things I'm saying about propositions here. What this means is that the same sentence may express different propositions in different contexts. If I say the sky is blue, this actually means something like the sky above my head is blue at the moment I'm speaking. Or the sky of Earth as it appears during this period of time. I should say, the sky of Earth as it exists during this period of time normally appears blue in the sky. So I may be saying something like one of these instead of just the idea here is that we have that the context informs what we're actually saying. There are various qualifications on what we're saying that are given to us by the context that we're speaking in, but we don't always say what those qualifications are. Okay. Also, consider the statement, religion is harmful. This does not express a proposition that is sometimes true or sometimes false depending on the religion. properly quantified, it expresses the proposition religion is sometimes harmful, or the proposition religion is always harmful. The former is true, and it does not mean the same as the latter, which is false. Now we move on to conjunctions. We have two rules involving conjunctions here. One is called conjunction. This is the rule for forming a conjunction from two premises. Let's say we have one premise and another, so we can infer the conjunction of them. That makes sense? Also, we have the rule of simplification. We begin with a conjunction, and we can infer one of the parts of the conjunction. We call these parts conjuncts. And if you look at the truth table of a conjunction here, you see two T's and two F's under the P, and a TF under the Q. This pattern of T's and F's gives us all four combinations of truth values for P and Q. And under the ampersand, we have the truth value of the whole expression. And it's true only where P and Q are both true. Otherwise, it is false. Let's look at some examples of these rules. Here, Bambi is a buck, Feline is a doe. Therefore, Bambi is a buck and Feline is a doe. That's an example of the rule of conjunction. As an example of the rule of simplification, we have Philip is a prince and Elizabeth is a queen. Therefore, Philip is a prince. We now move on to disjunctions. And a disjunction is an or statement. PVQ means that either P or Q is true. And note that this is an inclusive or, not the exclusive or, where one or the other is true and not both, but an inclusive or, where both can be true or just one can be true. Okay, with this in mind, that it's an inclusive or, let's say we have a single premise. We can infer the disjunction of that premise with another proposition. To give an example here, we have Neil is an astronaut. Therefore, Neil is an astronaut, or the moon is made of green cheese. And here it doesn't matter that we've added a false proposition to the original proposition here. Because the original proposition is true, the whole disjunct is true. The whole disjunction is true. We can add a true disjunct or a false disjunct, it doesn't matter. We could say Neil is an astronaut or Buzz is an astronaut. And that would be true as well. Okay. Here we have a disjunctive syllogism. This begins with a disjunction as the first premise, and the next premise is the denial of one of the disjuncts in the disjunction. And so we infer the other disjunct. And if we look at the truth table for the disjunction, we see that P or Q is true in the first three instances, and P is false only here among these first three. So we have only one line where both of the premises are true, and in that line Q is true. So we can infer Q from these two premises. And so that's an example of how we're using the truth table to verify the validity of this argument form. And here's an example of a disjunctive syllogism. Hubert is a hamster or a gerbil. Hubert is not a hamster. Therefore, Hubert is a gerbil. Okay, in our next video, we're going to be looking at material conditionals. There's not enough time in this video. Here are some of the sources I consulted while making this video. Copy's Symbolic Logic is the text I actually studied when I took symbolic logic in college. It's a very good text. And A.P. Martinich's Philosophical Writing is a book I highly recommend to philosophy students. It's the one book in this list that uses the exact same symbols as I'm using here. And Cohen and Nagel's An Introduction to Logic and Scientific Method was my main source for the details on propositions that I mentioned in this video. Thank you for watching, and stay tuned for the next video, which will be on material conditionals.